Hello everybody, welcome to this video lesson. In this video lesson, we would like to talk about digital electronics. We know we use many of the digital devices in our day-to-day life like smartwatches, mobiles, computers, laptops. All these things works on some basic concepts which are going to be discussed in the concept like digital electronics. So what is the basic logic, or else what are the basic things that we are going to have in digital electronics is a point of discussion today, right? So it works first of all on a language called digital language. So digital electronics works on a language called digital language, which is slightly different from binary number, slightly different from the decimal number of the system that we follow. We follow normally decimal system like whose numbers like 1, 2, 3, 4 and so on up to infinity. That's a decimal system. But the digital language is slightly different from that. Digital language has a system called something like binary number system. As the name says, it is just binary. It's only two numbers in the system, 0 and 1. Means what? Whatever you want to express in digital electronics or a digital number system, we express everything in terms of 0 and 1. To express this English language and the symbols, we have something like ANSI code. Similarly, American Standard System code. Similarly, to express our say decimal numbers, we have these numbers to be converted into this binary system. So before going further, let me first tell you that for say English alphabets, there is a standard codes, ANSI code, something like that. But how do you convert our decimal numbers into binary numbers? Let's first try to think of it, right? How do we convert decimal system of numbers into binary? There is a simple operation that we can say do that. I will do it by taking an example. Say for example, 20 is how much in binary system or in digital language? If that's the question, how do I handle that question? Simple. Let's take 20. Keep dividing with 2. 2 tens are 20. When I divide with 10, I am not getting any decimal. Remainder is 0. So there is 10. Again divide with 2. 2 5s are 10. So again decimal is remainder equal to 0. Again divide with 2. 2 2s are 4. See, here is a 5, but 2 2s are 4. That means there is a remainder 1 coming. Again divide with 2. 2 1s are 2. So the remainder is 0. So keep on dividing with 2 until you get a conversion in terms of zeros and ones. Your answer in decimal system has to be found in reverse. That means what? 20 in decimal equivalent in binary system is, I have to write from here. Yeah, I have to write from here to this line. How much? 1, this 1, 0, 1, 0 and 0. So we have just converted simply a binary decimal number into a binary number. This is how we are going to convert, or the systems or the devices are going to convert any of the decimal information into a binary information. Just for an example, let us consider one more. Say for example, 100 in decimal system. We know that is how much in binary system? Because it is 1 0 0, you cannot say it is anyway binary system. No, it's not a binary system. It is designed in terms of a decimal system. So I have to do with 100. Keep dividing with 2. 2 50s are 100. Remainder is 0. Again divided with 2. 2 25s are 50. Remainder is 0. Again divide with 2. 2 12s are 24. Remainder is 1. again divide with 2. 2 6 are 12, remainder is 0. Again divide with 2. 2 3s are 6, remainder is 0. Again divide with 2. 2 1s are 2, remainder is 1. See, now we have eliminated, and all answers are now obviously in terms of zeros and ones. You can see this is how I can express. So what is the equivalent value of this? So how can I say this is equivalent is? So I can say equivalent is, I have to say from here 1, then 1, then 0, then 0, then 1, then 0, then 0. So if you want to say 100 in binary system, you have to say this way, not this way. That's not 100 in binary system, that's 100 in decimal system. Whereas in binary system, this is 100. So this is how we can convert any of the decimal numbers into binary system. So digital electronics are the digital devices by default to make this conversion. If they don't do that, the computers, the chips, the logic gates, whatever you are talking, won't be able to understand these decimal numbers. They will be able to understand only everything in terms of zeros and ones. Therefore, as all electronic devices understand only binary language, what all the inputs that you give via, say, keyboard, mouse, what all you do, they all has to be binary language. All given inputs in other form need to be converted into binary systems. That's why all digital electronics understands only things like 0 and 1, nothing else. Fine, you understand there are only zeros and ones. Now we will go further in the next video lesson and see what kind of operations that we will be able to make in digital language and digital electronics. See you back in the next video lesson. Thank you.